camera is immediately behind your head.
So we don't need to do the mute echo. Somebody else.
Yeah, except when we want to uncue somebody. That's a mute button, a big red button.
Okay.
So if somebody wants to talk,
Okay.
we hit it.
Okay, 뭐야,
That's fast. They say thank you.
Shall we start? 4:20?
Oh, we should start.
Yeah, since we have a tight schedule. Okay, good afternoon, everybody. Thank you for coming to this session, Interface to Network Security Function. And here are the chairs, Adrian Farrell and myself, Linda Dunbar. And since we have a very tight schedule, we'll go on. Knows well. As of today, I mean, this is almost the last day of the week. So you have seen this page many times. So just to reemphasize, anything you said, anything you write under IETF IPR policy. A little bit administrative. Okay, the charter is on the web page. And we have a mailing list. So if you haven't subscribed to the mailing list, please do so. And thanks to Sue Harris, Frank Shah, and Diego for taking the notes. Thank you very, very much. And last, the blue sheet, please sign up and forward. And please move them around. Don't leave that by yourself. Okay, and the agenda and material have all been uploaded. And for the minutes taker, please use the Etherpad, make it easier to work together. So here are the agenda. And thanks to all the contributors, we actually have lots of drafts. And to make this meeting productive, we already had 2 side meetings. One among the drafts for the NSF-facing authors to consolidate the differences and merge some drafts. Another one is this morning we did client-facing interface. So with that, we be able to shrink down the number of drafts. But still, it is a very tight schedule. So hopefully we hold our questions to the end. And if we still didn't finish all the questions, we can bring to the mailing list or after the session. Okay, so the milestones, and we have already had 4 working group drafts. I think 3 of them are pretty much ready for the working group last call, and there's one terminology still need probably some time. And we also have on our milestone the requirements and the information model and data model to be adopted by the working group. And so hopefully people pay some attention to those drafts, and hopefully we'll call for adoption between this meeting and next meeting. And here are the future milestones. I don't have to go through them. They are all on our working group webpage. Okay, and also the wiki page. Please don't forget them. And for any issues or any ideas, please put in there. Like some people are discussing for the next IETF hackathon for the I2NSF features. All those documents should be uploaded to this wiki page. And with that, and I will leave it to the first one on the agenda, the problem statement and use case update. Okay.
Good afternoon. I'm Sue Harris. I'm the current editor on the draft problem statement and use cases. At the last ITF, I said, oh, it's ready to ship. I think that's because we've been talking about it for a while and we just sort of had run out of additional new contributions. Thanks to Ragesh and other people, go ahead to the next page. The problem statement is in really good shape. I haven't found anyone to make any comment on the problem statement. However, some people have suggested that the use cases need additional piece for both service provider and enterprise. My suggestion is you work with a little extra text. If you think you want to have a draft on it, great, but send some additional text and then send some to the list so that we can discuss it, and then I'll be glad to work pretty proactively with anyone who says we need new use cases in service provider. And then we need to do an initial sector review. But please, if you've got use cases you think aren't in there, be proactive right now and get it done. Send me comments. Send it to the list. Don't be shy about filling my email box or filling the list with comments. That's a good thing. Okay, I think that's, and this is a set of things that Rakesh suggested. Please read the slide. In interest of time, I'm not going to read slides, guys. And there are branch and campus data center. Please just send comments on whether we got the use cases done. Read the slides online. Is that okay, Chairs, if I'm brief? Brief is good.
And next one is the gap analysis.
Yes.
That's also yours.
Okay. The gap analysis, bad to me. I only got its second version this morning. Sorry, Chairs. But I did 8021X, I did AE MaxSec, and I did AR. If there's anything else left in the gap analysis, please send me a note, and I will try to. There are seats up here, guys. We'll let Kathleen sit in the front, right?
Sure.
Okay, so please read it and suggest additions. If you find any text, same thing with the use case and problem statement. Be proactive. Send this. Send me as an editor comments. Tell me if you think something's not worded right. We want to sort of progress this quickly to working group last call. And that's the end of my talks, unless there's a question.
So you, with the gap analysis, you think you've done everything that had been raised to you as an issue. So
Yes, on
you
the
think
gap.
you think it's cooked?
I think that it's cooked, but you know,
Oh yeah, but there are other people in the working group.
there are other people in the working group. I've done everything that I think I was supposed to do. Same thing with the problem statement. I did everything I was supposed to, but based on good feedback, I'm glad to work again.
Lovely. Then I'd like the working group to take this as a sort of pre-working group last call. So start reading it now to raise your issues so you can get them to Sue before their surprises in last call.
And this is a really great 2 to 3 weeks. If you're just taking a break on the way home, read it and then send me comments, because I have a lot of time to just quick put the text in. Thank you.
Thank you, Sue. And next one is Diego, the framework update.
Okay, yeah. I hope this is just a slide of for you to remind you what the whole thing is about. So I think we can skip it unless you have any comments, just for reference. And this is how it is shown is now shown in the draft. That if you look at, if you remember, Buenos Aires has changed a little bit, mostly in two things. One in the names of the interfaces that now. And this is something that we will have to go through in the terminology discussion. Now they are called client-facing interface, any NSF-facing interface, not any longer capability or service interface, but probably will change again. So don't hold your breath, and a little bit on the descriptions. That again is just to make things a little bit better aligned with the view that we have now. Next one, please. So main changes. We have aligned the diagram with the current terminology and the rest of the documents, and this is something that we have made is a change all over the document changing developer instead of vendor. Essentially, because of two reasons. One is because, in general, not all developers need to be vendors, but all the vendors will be developers one way or another. And well, it is nice to our fellow open source projects all over the world to refer them as that way. So the document flow has been improved. So we have tried to provide a better glue among the different, because this document comes from several drafts that were contributed independently. So we have made what we believe is a better glue to tell a story that is consistent. And second, probably we would need to adapt it a little bit more, make the whole thing work by probably even cutting some parts and adding some and filling some of the gaps as still maybe in the document. In particular, we have incorporated a couple of sections from the attestation draft. In the attestation draft, originally we have a discussion on threats that were very much oriented to virtualized environments. We have adapted it to analyze whether we're going to have a network security function that is not in your administrative domain, and the requirements of the controller, client controller interface. So instead, the text has been cut and pasted here. So now there are references in the attestation draft. Next one, please. So what comes after? Keep consolidating the alignment with other directly related drafts, in particular the one on terminology, the one on use cases, the one of the gap analysis. I think that these 4 drafts should walk in parallel to the path of becoming formally accepted or published. This is something that probably we have to sort out, or the chairs have to decide, or Kathleen has a word on it precisely to have a clear view of how whether we publish or what we publish of the 4th draft. And well, we will keep doing the gathering work, including possibly requirements from other documents that many of them will be discussed today. And I think this is the most important thing that we have to do, is having a final assessment on the structure. One we are reasonably glad, and for that, very likely, I would ask to look for a couple of fresh eyes, at least. Someone that is not familiar with this, that hasn't been part of the gang, and can tell us whether it's easy to understand, whether there is any gap or any problem. And that's all.
Thank you, Diego. Yeah.
Look, we have sent it some comments framework to the alias, but I think we have few discussions on that framework. Sorry.
No, your name.
Oh, my name,
Okay.
Rakesh Kumar. Sorry, it's my first IETF, so excuse me. So Diego, some of the
So
things
you pay $10 now. For the
Your name and company.
Okay, Rakesh Kumar from Juniper Networks.
$20.
So basically, we have talked about the framework. We have given some comment to the email alias, and I think we'll probably get opportunity to talk some more. And Anil and I have taken more detailed comments about basically how to align framework with the charter. And what we are saying is we don't care about how things implement it, blah, blah, blah. I mean, there are a lot of details, so maybe we can sit down and send you the detailed comments we have taken.
Yeah, I would say that the best thing we can do is that you send it to the list. Sure. And we openly discuss
Sure,
it.
we will. Yeah. We have sent in the past, but that was not detailed. We'll send more detail.
Yeah.
Okay, that's all.
So Diego, my feeling on this draft is that you expect it to be fairly long-lived to keep up with other developments.
Yeah, that's true. Yeah, no, I mean, at the end, it will be the initial reference document, but to make it initial, really, it's curious how the process is, yes. Am I dismissed?
Thank you. And the blue sheet, can you please, who has the blue sheet? Oh, please pass around. Next one is the terminology, John Strasner.
Hi, so you hopefully all know the draft motivation and goals, so I won't bother you with that. We had some interesting homework from our beloved chairs from IETF 95, which was go out and examine SACM and see if there's anything interesting there. Indeed, there was. And so if we click, there are a number of changes that we've made by having some detailed discussions with the SACM terminology team and also the SACM architecture team. For this version of the draft, we imported 3 terms: assertion, authentication, authorization. We made some minor changes, so these aren't quote for quote the same in SACM, but they're very similar. So controller, control plane, and SACM used our capability, but SACM style was to have term and then SACM term. So we've done that inconsistently, so I added I2NSF capability, since that's a central tenet in our information model and architecture. SACM has taken other definitions from us, SACM component, SACM interface, SACM role, and there will be a lot more to report in this in the next IETF. The cooperation's going well. And much like a famous parrot, any virtualization term has ceased to be click. Homework. Now there was additional homework. They loved the terminology authors apparently. And so they wanted us to say, well, what do you think about these 4 pairs of terms? So consumer versus client versus requester, the terminology draft currently uses consumer. It uses consumer because client, to at least to anal retentive people like myself, implies a client server architecture, or if there's a lot of wind behind it, maybe a 3-tier architecture, but not necessarily a distributed architecture, which is what I think we're trying to build. That being said, we took a stake in the ground. We pointed client to consumer everywhere in the terminology, and we'd love more feedback. Producer versus controller. Well, if you've got a consumer, then it'd be natural to have a producer. So that was a no-brainer. There were some other comments on an off list that, gee, doesn't controller mean SDN controller? I personally hope not, but that was a concern. Capability interface versus capability layer. Hopefully all layer terms are getting sent to at least the 7th region of hell. The problem with layer is the same as the problem with northbound and southbound. It implies this absolute reference system, and never something below a layer is allowed to go above the layer, and that's just not true in modern day software. So I at least personally vote for interface, but that's something that needs to be decided per our chairs. The same thing with service interface versus service layer. I would hope that there's a meta constraint that if we choose interface for the one, we don't choose layer for the other. Click. Next steps, we're going to keep this updated regularly. So anytime with our methodology that I blazed through, anytime we have new terminology introduced or existing terminology changed in the main set of drafts, we will update the terminology draft. So there should be a number of changes until our main drafts are stable, and then this should hopefully just be done. That's it. That's about as fast as I can go. Questions? Yay.
Thank you.
Well, don't run away so fast. So I was actually expecting that you would get questions, because I was expecting people to come and say, I've looked at term foo in your draft and I think it should be bar or something like that. But maybe what needs to happen is that we need to start all converging our drafts onto this terminology. I know some of the ones we've talked about earlier have been doing that as we went along, but as you're writing new drafts and pushing them forward, you need to be picking up this terminology, being very clean, not using other terms which mean similar things or the same thing and causing confusion. And as you do that, if you find that you're not particularly happy with a term or a definition, you need to raise it before this stuff gets set in stone and you find yourself lost.
Agreed. And I guess to augment that, the terminology authors can play the role of police. And if we find something in our review, we can say, that was a no-no, we need to reconcile.
Okay. That goes very well.
Wow.
Um,
We're steaming along now, which is good because the bottom of the agenda was going to get squeezed.
yes. So next one, Rakesh.
This is pretty big, I think.
Okay. Oh, sorry.
So this morning, Linda got, there were a lot of draft on the client side, what the client side interface requirements are, and there have been multiple drafts. And Juniper also posted a draft. And this morning we have a meeting how to consolidate all those drafts and put together one requirement, basically that will determine what the requirements are from the client side. So that the attempt has been made in order to get what those requirements are. But before to do that, like Diego was saying, that somebody can look at a fresh eye. We just started in this working group very recently, NNI, and we just look at what I2NF is doing. And we are in the security industry, but so far we have not participated in this. So we want to take a look at it, how I2NSF framework works, how it aligns, and how we think we'll go forward. So in few slides, we put together our thoughts, what our I2NSF agenda is, so that we can present our viewpoint, what the client interface look like. We go to the next slide. So agenda is what is a security controller architecture, what is the I2NSF framework for controller, and then from that, let's figure out what the I2NSF client-facing interface requirement would be. And what we want to do is, if there is a way, we can leverage SUPA policy to drive those client interface. And the reason why we took that approach, or we want to take that approach, is because a lot of the security functionality, whether Cisco, Juniper, or Huawei, or any other vendor, a lot of times those security functionality configured through some kind of policy interface. Policy could be CLI driven, or policy could be management system. But there is some kind of policy framework that drives all those, creating the security posture. And this is the draft we have proposed that. Can you go to the next? Yeah. So this is what we have. And this is more like a simplistic view, which has been defined in Charter to some extent. And this is our interpretation. The security controller is a system. Again, we are not going to detail of what security controller is, how a vendor developed that, what the implementation detail are, whether it's a one blob, or there are multiple functionality, how does it topology discovery, blah, blah, blah. So the point is here is I2NSF Charter is to have two interfaces, I2NSF NSF facing interface, which are actually going to program the network security function. And the purpose is to create this interface so that this is agnostic to which the vendor is, whether it's a virtual form factor, physical form factor, or a particular security policy can be programmed in a router, switch, virtual, physical. And on the node-bound side is, or on the client-facing side, or whatever terminology we agree on, is what the interface we give it to other system. Other system could be OSS, BSS, application controller for the service layer, or it could be very well that somebody, large enterprise, they want to write their own application, or they want to develop their own portal. So this is the basic top-level view, what we understood from the Charter, and based on what we think is what they're trying to say. Can we go to the next slide? And this is another representation of that, where, like in the previous slide, this I2NSF agent, just like we do it in OpenStack and other virtual framework, that somebody takes those requirements or those API, and the agent sits in the device or network security function at that interface, and when convert it to the device specific or the function specific requirement. Here you have a proxy management system, or you can call that I2NSF agent, which takes all those southbound from the controller, and then vendor could implement their own proprietary function if they choose that. But the point we are trying to make is, no matter what your architecture is, like in the Vim layer, in the OpenStack, doesn't matter how you build your physical virtual security controller interface, node-bound, southbound, can still work in any deployment scenario. So that's what the reason. So go to the next slide. So this is what we thought by, as I said, by reading on what the I2NSF framework is trying to achieve and what the goal is. So on the client side, let's create interfaces. Again, this is what we think. I'm not saying this is set in stone. So security control interface to intent. As I said earlier, we really don't care what the top level application is. Could be GUI portal, RESTful API, template internal, somebody could write natural language processing. We really don't care. Our goal is to provide a Yang model or the API, which could be consumed by anyone. And it should be agnostic of network topology, NSF location in the network to some extent. Of course, there might be a use cases always where you might to know, hey, these are the IP address, I know where they sit, and I want to use that as a policy language to program the southbound interfaces. And if possible, like I said, leverage super interface. On the I2NSF or the southbound side, the control interface is basically the whole purpose is to configure NSF system, whether it's a virtual, physical from any vendor, and get the operational state. Operational state could be once you program a policy, you want to see whether the policy is being active, and if there's a violation, you want to get notification, or if you want to get the telemetry information. And as I said earlier, our view of the southbound interface is, in principle, it should be agnostic to vendor implementation form factor, agnostic to how NSF is implemented. And the reason for that is it's not IETF charter or iTunes charter to tell a NSF vendor how that functionality is actually implemented in a data path. Or if you want to create a cluster of NSF and make it look like one single entity for a higher layer, that's none of our business how they implement that. So basically just capture some of the things from that perspective. So that's more like a guiding principle of how we'll define this interface. So can we go to the next slide? So this is at the end of the day, we have to define the client-facing requirement. And here what we're saying is there are multiple different requirements which build a user's policy. This could be a metadata-driven groups. Groups could be user group, device group, application group, location group. User group could be, let's say, HR user, finance user. Because you want to create a policy, let's say HR user cannot access the finance application or vice versa. Then the device group. Device group is maybe you want to club all your devices, let's say Windows machine, into one group, and you want to create a security policy only for that specific group. And the second could be Linux device, maybe the kind of software they're running. Maybe they have some security hole there, and you want to group them, and you want to apply a certain patch or certain specific policy on that particular group. Same group could be based on the application. Like I said there, you want to say that, hey, certain user group cannot access certain like application group, like finance, legal in an enterprise. They might have critical application. For that, they don't want to give access to all the users. And the last thing, but not the least, is location group, where enterprise or service provider for their own on their infrastructure, they could create a different security posture based on the location. Let's say my sites in Asia, I want to have different security posture. Site in my one region may have different security posture. So this is basically metadata group. But like we are saying, the group definition doesn't mean it has to be us. Somebody has to build a system based on Active Directory, LDAP. We are not mandating that. What we are saying is, if you want to use metadata groups, you could do that. But if you want to create a fixed group where you don't want to build information based on the identity system, you could do that too by creating a fixed mapping. And the next thing is a policy modeling requirement. So this is more from user intent, what meaning the groups. When the user wants to attach a policy, what kind of things they want to attach the policy or what component they want to use when they build a policy. So just one video. So policy lifecycle management. At the end of the day, when somebody configure a policy, user want to say that, hey, if I configure a policy, I want this policy to be active all the time. Or you can create a time profile that during the night, I want policy to be active. So policy may be configured, but may not be active. So that's the point we're trying to make. And same thing, policy could be driven by event. You could say that, hey, suddenly at some point in time, I see a bigger threat, or suddenly I see some event, and I want to change my security posture. So you know, not necessarily you have to know what policy in the program I want to provision. You could pre-provision a system, and system could act based on the event and automatically change the security posture. That's the next one. And the policy rules. So again, this is not supposed to be the exhaustive list, but this is what in experience we have seen so far, like threat management. So in the rules could have, let's say, botnet. I want to prevent the botnet access. or I want to hand malware, DDoS handling, parental control, application threat, and you could create this policy for the intergroup access, for the intragroup access, and the policy action could be permit, deny, meeting. Again, this is not trying to be exhaustive list. This is just a start. What kind of abstraction we do from the I2NSF layer so that we can build the client layer interface. I think that's there's more last year. The next thing is authentication requirement. Like any system, any application, there may be various kind of authentication requirement. Maybe some customer like username password, some customer like maybe PKI security based, somebody like mutual authentication. So we are not mandating what should be, but we are saying is there is a requirement to do authentication. Then there is an authorization requirement. So like a multi-tenant system or even a single tenant system, you don't want to give all the control to all the user. So let's say if somebody logs into your security policy controller, based on what role they play, you want to give them the access. Maybe not everybody can configure a policy. Some can configure, some can only view. Then their operational requirement, like I said, then multi-tenancy, telemetry, notification, affinity, capabilities, test interface. I'm trying to go very quickly. The reason is that there are lots of requirements like that when we build interface. So to be honest with you, right now user already uses this different security product and program all this policy. So whatever we are saying, it's not that it's not being done today, but the way it is done is every vendor have their own proprietary interface, and when any enterprise or any service provider want to integrate with that, either they have to adopt to those API or they have to know the CLI or integrate with the management system. So the whole idea is how to make this framework vendor agnostic, and it does not matter how the security function is implemented. I think that's pretty much it.
Any questions?
John Strassner. So thanks for a very interesting presentation. On this slide, I think it would help if you gave some examples, right? So, I mean, you've got simple things like MAC and DAC, and then you've got more complex things like RBAC or ABAC, right? That might make it easier for people to understand what you want. If you go back to 1 of 3, so if you go back 2 slides. Yeah, so I have the benefit of being in a side meeting with Rakesh, but just in case this comes up later, when he says user intent modeling, he doesn't mean policy-based intent, right? He means simply what the user wants. And then I actually like the metadata-driven group characteristics a lot. Now, in the information model, we already have metadata, so that maps perfectly, but we don't call out this is an additional area that metadata could be used for. So I think that that's excellent, and we will, as we merge the information model drafts, we will try and take that into account. And then one last thing, groups is just a type of role, right? So it's an abstraction mechanism, and there's lots of different examples, but I support the requirements.
Thank you very much.
Thank you. If there's no other question, I do have a question for your last testing, the test interface.
Yeah.
Is it similar like a query? Like you test whether the client request can be implemented?
So I'll tell you this, like, as I said, we are developing some product, and I have an advantage of talking to a lot of customers. What sometimes people really want is, let's say you want to change the security posture of your framework. You really want to do it, but you don't know all the implications. So you want to say that, hey, I really don't want to do this. I want to see what implication has. So test interface is more like a generic thing, and we can expand more later on. So the reason we put that, this is really like customer really want, where they don't have to configure it, but it test it for 2 reasons. What the new security posture look like, that's one way. Second thing is whether my framework can program that, because you could run out of the resources. Let's say I want to program some policy, and I have 10,000 rules, I'm just making something, and you already use those. I don't know that. Yes, you can always provide interface to user, can figure out the latest capability, but that's the whole idea behind this user intent model is, where user doesn't know there's an ACL sitting on the router and what is its capacity. All you care, this is a new rule. Can you add it? Yes, you can add it and it will get rejected. So test, you can test it, just like we do in the, like when enterprise deploy application, they have a development zone, they have production zone. In the development zone, they test this. In the production zone, they actually deploy. So think like that. That's the whole idea.
Okay.
Developers, a couple of reflections. When would you talk about the test interface? Thinking about that, what you were discussing, is that in many other places you see OEM. Maybe just because of consistency with what other groups are doing, probably we could use OEM, simply as a suggestion. What a couple of other things that come to my mind. One of the notes when I started to read your draft is the idea of the policy, which is, policy combination or policy reconciliation, because in what we have done in the secured project precisely is that we identified that very likely you have several sources of policy. I mean, you can, for example, in a company, if you're following this bring your own device policy, you can have the policy of the company, even the policy of the network provider of your company, and the policy you want to enforce on your device. And this would be something that I think it would be worth mentioning. Okay. This is one thing. Second is that we had to talk about how we reconcile this with the attestation draft, because there are things that are related there, and we had to find. The attestation draft speaks or talks about several levels of assurance. Probably what we are talking about here is the lowest level of assurance. And in other ones, what you would require are precisely mutual authentication, using of certificates, having the attestation keys in a trusted third party, things like that. So this is something that we have to.
No, you're right. And we, as I said, we look toward guidance from everyone. So the reason we didn't put any specific thing there is, let's say if I put one specific thing, other might say that, hey, I didn't put my requirement. So I don't know what the language you use, like shall, must, or guidelines. I don't know. We can discuss more. This is just a starting point. Like I said, that this is what we think. Now, how to take this work, move forward, expand the detail. As I said, that this is a starting point.
Okay.
Thank you very much. So next one is Daniel. This is still the client-facing interface.
Hi. So collaboration agreement for security service. So the motivation is really to enable different security domains to collaborate together. So for example, if you have a web application or a web server that notice that it is under attack, it does not have necessarily all the informations and the power to mitigate this attack. So it's probably sent to an orchestrator, I'm under attack, and then it's up to the orchestrator to say, well, let's configure at the border some firewall rules, for example. But sometimes we can do a little bit more, and we can say, well, instead of just securing the domain, well, the DDoS might be mitigated outside the domain. So if you have a distributed denial of service attack, you can have a distributed mitigation also. So yes, we can do more. And so the difference between collaboration and orchestration is a bit the difference between a master-slave and peer-to-peer. So your collaborator, well, potential collaborator do need to have the ability to say, no, I'm too busy. And you may also have to say, okay, I'm going to help you, but up to this amount of resource or up to these things. So what we need to have is something that is flexible and that is not, well, someone is not taking your control of your domain, even though you're providing some collaborations. So one of the things we define is what we call the best effort mode, which consists of, if you're asking to one service function to treat some traffic, the service function can say, okay, I'm going to treat part of this traffic, sending the treated traffic to one path and sending the other traffic to another path. So this is what we call the best effort, for example. And this allows for the provider just to engage a very few resources. So next slide. So, well, the collaboration, well, if we want to set a collaboration, so we have a contract, and setting this collaboration is agreeing on this contract. This contract involves some, well, how we collaborate, the resource, and the type of service. So for now, we have some, if you have any feedback to express the resource, what would you, because there is no standard way to express the resource, we can use C group terminology, we can use Amazon Web Services technical terminology. And similarly for the service function, we don't, well, if I'm asking what is a firewall, I will have probably more response than the people in the room. So that's part of the missing things we need. Suzanne?
So this is interesting. Luan Feng had an intercloud API. Have you read and looked at that one?
No. Which?
Okay. It's an intercloud DDoS provider API.
Okay.
And then I wrote a Yang model on that. And this looks a whole lot like it, just slightly different. So it may be enough to be different. It may be enough to be the same. I mean,
Yeah.
that because it's a user interface, that would be fine if it's slightly different. But I thought it might be a good thing to look at, because if it's close enough, then that's more benefit for the Yang model.
Yeah, definitely. So can you send me the link to?
Sure, I'll send it to the list.
Okay, to the list. That's good. And so, yeah, that's definitely useful, because if it's already there, maybe it's better for us.
Luan is from Microsoft, so she's using her operational.
Okay, so that's a good thing.
Repeat that, Chairs or something?
So that draft is about like you have data center network. You want your carrier to be able to filter some flows, and they want to be able to have the interface to tell the carrier what to do, and also query if the carrier can do it or not between their data center network.
Definitely, I will have a look at that. And well, I think that someone provided me a Mohammed. I don't know if it's there. Provide me also another link I will send to the mailing list. It's about resource provisioning or negotiation, so that's could also be correlated. So, well, collaboration, how it works, basically we have a set of proposals, and you have to choose, well, if you're willing to collaborate, you say, okay, this is a proposal I'm accepting, and then the collaboration is set. It works a little bit like IVV2. Next slide. So, while collaborations comes with a few management operations, but what we would like is to have very little things. We don't want to, for example, if I'm asking for the other domain to instantiate a firewall, configuration of the firewall is just outside the scope of setting a collaboration. So we would like to have a very light protocol at the end. Next slide. So, yeah. We have a Yang model, it looks like. I'm going to look at all these alternatives. So if you see anything that looks like what I'm presenting, I would be more than happy that you send that to the mailing list and maybe come back next IETF, or at least I will provide an update.
So, another thing, no, before you, we have to come back. Diego Lopez again. There was yesterday, we had I don't know if to call it a verb-off on the IETF, in which we were talking about blockchains and contracts and smart contracts and this kind of stuff. Looking at what you were presenting, I thought that it could be a very interesting use case for, I mean, this is not something that is going to happen for next IETF, but at least exploring precisely this kind of possibilities of using the services is something that was discussed there in the meeting. It would be really interesting if you
Okay.
if you come. The list is DIN, DIN,
Okay.
like a Deutsche Industrie Normen.
Okay.
That, by the way, is what started the hi-fi that gets named to the Wi-Fi. Just for you to know.
Hi, Daniel. It's Frank Xia, Huawei. Just a little question. I think your proposal is also about ask for help of when your domain are attacked, and you ask a help to another domain. So what is
No.
major difference from current
Okay.
working dots? Can you elaborate?
So it's not about alerting something. I mean, dots is, you notice you're under attack, you're not able to mitigate that, you ask for help outside or inside, or I mean, to something. Here, it's more, I know what I want, I know what I need, and I'm asking for a specific service.
Okay.
So, I mean, it could be the same if we are asking for if we had one service saying you are the anti-DDoS service. But I mean, we're,
Okay, I understand it. Yeah, that's just
yeah.
ask for help, but this you may want more. You know what is the objective, what is your provision requirement. So I think, yeah,
So-
there are some different. Yeah.
Yeah, it's I mean, well, what we would like to use is if you want to use that in combination of dots would be the signal and sent to the orchestrator, and the orchestrator would use that for the different domain to orchestrate.
Cataldo Basile, Politecnico di Torino. First of all, I think it is a very interesting use case of a service that is built on top of a capability layer that one of the main outcome of the working group. And then as a suggestion, what I would like to see in the future version of the draft is an alignment, because now we have several drafts about capability interfaces and models, but this is a way to actually use and show how this can be useful, and maybe we can have more requirements for building a more coherent and consistent capability layer. So maybe in the future.
And so
versions
all the
we-
drafts, are they in the IRTF working group?
Yes,
Okay.
there will be a few left draft after this ITF meeting, but now there are 3 or 4 drafts about capabilities. Then we will have probably only 1 or a couple.
Okay. I think it would be useful to send a pointer to the working group,
Oh, yeah.
IRTF working group, so that people.
No, he meant is
No,
this
it's
working
in
group.
this working.
In
Oh,
this
in this
working,
working
yeah,
group,
yeah,
okay.
you will go to see the lots of capability drafts.
Yeah.
Well, in the interest of time, we have to cut it really short. Do you have just very quick question or is it a long question?
I think it's a quick question.
Okay.
If it's not, I'll take it. So,
Okay.
Roman Danilio, I'm DOTS co-chair. So, Daniel, can you clarify? So, in DOTS parlance, are we saying, I heard you say signal channel, and that's why I got up to ask. I thought this was the DOTS server talking to the mitigator, which is the comms that's at a scope with DOTS. You're talking this is signal channel, so
No, this one is if you are if you're negotiating some resource, you're mitigating. It's not intended to send an alert, whereas you are under attack or not.
so it's the DOTS server talking to the thing that's going to do the mitigation, right? It's literally the one, like, it's about the comm saying, I'm now doing the blocking, which is the stuff we don't do in DOTS.
Well, no, I think, well, they are not, when you use that protocol, you're not under attack, or you're sufficiently strong to handle this attack. Sorry? This one,
Which-
the collaboration.
No, this is Kathleen Moriarty. So I sat through the DOTS presentation. I had the same understanding as Roman. So I guess I'm confused now.
Okay, so, well,
Well, he's not the only one.
so my understanding of the question was, can it be used by the DOT server to orchestrate the mitigation?
Right. So in DOTS, the thing that's in scope is I need help. So I mean, you know, the DOTS architecture,
Yeah.
it's the client talking to the server. The thing that's not in scope for DOTS is the server now is supposed to talk to something that's going to do the mitigation related to the denial of service. So we're not,
Yeah.
you know, DOTS is not trying to work on that. So the question I'm asking, is that the use case
Yeah.
of here?
Okay. Yeah, it could be.
Okay.
But
That's-
but it's
Yeah.
Yeah, that's what I thought too.
but it's
Okay.
never to, well, it's not going to be replace the client anyway.
Okay, makes sense. It's
That's
just,
it.
I heard
Okay,
you,
yeah,
I
yeah.
thought I heard you say DOTS signal channel and I was
No,
got
no.
confused.
No,
Sorry,
no.
thank you.
Okay, thank you very much. And next one is a user group-based policy. Actually, this is related to the requirement about the meta groups, and this is just one group on the user groups. Also for the blue sheet, please pass to the front if you finished. Okay, it's your turn over there. Anybody has blue sheet? Okay, go on.
Hello, my name is Genji Yu. This is about user group-based security policy for service layer. Next, please. This draft was first presented at Yokohama meeting. And according to the comments received during that meeting, we added the AAA server as a part of the framework in I2NSF architecture, and we also add some clarifications. And it was presented again at last Buenos Aires meeting. And the updates are we update the references and add and clarify the actions, and we also add the security considerations. Next, please. Since we have presented twice at the meeting, we go quickly for the background of the user group-based security policy. As we know, in the newer network paradigms, user access the network is more flexible. It can access the network anytime and anywhere. So how to allow the user to have the consistent security policy pose challenges to the network security management and enforcement. Next, please. In the traditional network access control, typically user access the network from their static location, for example, so VLAN and IP subnet. So usually a MAC and IP address is used as a proxy for user's identity. Accordingly, firewall, for example, they use the IP address or MAC address to fill the users. Next, please. Next slide. Okay. So we propose a user group aware policy control. It is intended to facilitate the consistent enforcement of policies. For example, the security policies should be consistently enforced based on user group instead of MAC address or IP addresses. So whatever the network accessing network type and device types, the users should have the consistent, coherent security policies in their entire network. Next, please. Okay. In the UAPC framework, we measure there are 4 functional identities: policy server, security controller, AAA server, and network security functions. Our goal is to apply appropriate user group identity-based network security policies throughout the network. Next, please. So for the policy server, it holds the user group criteria and the rule base. For the AAA server, authenticates users and performs associated authorization and accounting functions. Security controller coordinates various network security related tasks on the set of the NSFs. Network security function doing the packed classification and policy enforcement, and also present the capability layer APIs. Next, please. So what is user group? User group has an identifier that represents the collective identities of a group of users. It is controlled by one or more policy rules. For example, source IP and location, time of day, device type, etc. For example, R&D user group, it's a user group ID 10. It represents the R&D employees. Next, please. Intergroup policy enforcement. And we also defined the user group to group user group access policies. Let's think about the firewall. Firewall role-based, but with the user group instead of IPs and ports. For example, the source group is R&D group, and the destination group, for example, is the working flow group. And from this table, R&D group can access the working flow group, but for the R&D BYOD group, it should have some traffic rating policies when accessing workflow group. That is the user group to user group access policies. Next, please. This diagram shows the intergroup policies. User at office hours, it can access the important services, but for user at non-office hours, it can only access the limited services. So that's the difference when based on the user group ID. So next, please. This is the example for UAPC implementation. First, we need to define the user group identification policies and intergroup user group access policies on the policy server, step 1. And all the policies would be implemented on the network service functions. So when the user attached to the network, it is first authenticated by the AAA server. And if the authentication is successful, the user will be put into a user group. So when the traffic arrived on the network service functions, it will be enforced according security functions based on their user group ID. Next, please. Requirements for the I2NSF. First, we need to have the user group classification policies database on the policy server, and the inter-user group access policy rules based on the policy server, and the inventory of NSFs and management by the security controller. The last is we have the list of NSFs on which are given into user group policy to be implemented by the security controller. So next, please. Last one. Okay. We have a follow-up draft for this service layer draft. It will be presented after. It is the capability layer for the user group based security policy. So if you want to know the more details, you can also read that draft. And it has been presented twice, and all the comments I think hasn't been reflected in the latest version. So we think the draft is stable and could be accepted as a WGDoc. Thank you. Comments?
Kesh Kumar, Juniper Network. It's like earlier slide you suggested AAA as a like authentication server. So this is more like a general question. Do we in this group do we have to tell which one to use? Just as an example, I'm assuming you mean just an example, not saying that for this you use AAA, because I could say I've used not even AAA, I use LDAP, Active Directory, I can use anything from open source. So I'm just saying is, going forward, are we going to, this is more like example, I'm assuming?
You mean AAA in the architecture?
Yeah, from AAA server, like for authentication.
Okay.
I'm just curious, is that, I'm assuming it's just an example, right?
Actually, in our first version, we
Hello?
didn't include AAA in the architecture, but I think people raised the comments that when you do the authentication, the AAA need to be participated, and then we make it explicitly in the figure.
No, but what I'm saying is I don't have to deploy AAA. I can use it, so many other identity management system. That's all I'm saying. I mean, I'm just saying AAA is, some customers use AAA, some may use LDAP, Active Directory, some may use totally different thing. All I'm just saying is, do we have to mandate that's what we use? That's all I'm asking.
Okay, so you mean that maybe have a more general user data?
Yeah, like you can choose
server.
anything you want. I mean, it's not in our working charter to say only use this. That's
Yeah.
what I'm saying.
Okay, so AAA just can be our example to.
This is what I would
Oh,
do.
okay.
You have AAA is just accounting authentication authorizations. It could be anything. It could be radius, it could be diameter, it could be LDAP, and the specific product Active Directory speaks all three. Well, I don't know if it speaks diameter, probably does, but AAA is a pretty generic name for the authorization, authentication, and accounting function. Well, perhaps, but if they do that, they're wrong.
Yeah, so it wouldn't be an IETF presentation if you didn't end with, can we adopt this as a working group draft? The chairs need to spend some time looking at the next milestones in the charter and working out what fits best and whether we need to pull some drafts together or adopt some things.
Okay, thank you.
Thank you. So the next one is SDN Security Services.
Hello, my name is Jaehoon Porjung from SKKU in Korea. This work is a collaboration work with Korea Telecom and Atri in Korea. So the update from the previous the version 4. So recently we submitted 4 draft can be integrated into this framework. So first of all, we updated the terminology based on the recent terminology draft, and then the first new draft is we can using the Yang data model. The Sujan will present after my presentation probably, and then this model will be integrated into the Su Yang model. And the second draft, we are proposing the architecture for security management, the client-facing interface, how to deliver policy into the security controller. Also, new security attack is detected by NSF security function, how to report toward the application layer client side, and then disseminate the problem into the multiple security controller. And also, the last one is how to enforce the security policy in the virtual machine layer, which means we can implement our information model using service function chaining, SFC. So I will explain later on. So next slide, please. So currently we are making the VoIP LTE with the Korea Telecom for the I2NSF framework. Okay, so this is a client, and then currently we providing the blacklist for the possible hacker, and then delivering this information using a client-facing interface, and then security controller translate based on ECA the paradigm, And then this information is delivered to VoIP, the DPI module. This is the network security function. Next slide, please. So we implemented based on the open daylight. So I2NS client deliver black box, the blacklist information using the client-facing interface, and then translate, and then the NSF, the facing interface deliver using netconf YANG, and then the VoIP, and this is a SDN network, okay, security controller, and the security function interact with the handle the firewall or some DPI service, especially the firewall is delivered this, the performed this. Also, in the meanwhile, some VoIP traffic should be mirrored and also the analyzed to tell this is the possible the misuse by the hacker or not. So this and the DPI, this security function and security controller should be interactive with each other. Next slide, please. So we implemented this one, and also we consider to reinforce this. We have to consider how to realize in terms of the security function layer. So we propose client-facing interface and also registration interface should be developed. So by next SOAR meeting, we try to show using some hackathon. So we demonstrate also you can the hands-on activity for this. Okay, that's all. Yeah.
Okay. Any questions for this one? No, can go to another. That's good.
Okay. So next one is we explain security management, the architecture. So I think this architecture can be integrated into the framework. So we have one step more. So next slide, please. So next. So the motivation is next slide. You can see one I2NS client, such as Korea Telecom, for example. They have a domain, the center client, that deliver the policy into multiple data centers. Okay, so each data center has security controller, and then each data center has multiple network security functions. So the question is, if network security function detect a new some malware or some DDoS attack, right? So in that case, that information should be propagated into the data center, right? So our architecture show how to implement this. Next slide, please. So objective is we are providing generic management architecture. We have a more detailed some component for our I2NSF framework, and also we are providing some feedback the control loop to propagate the new detected attack to the whole network security functions. Next slide, please. So this figure shows the upper layer. This is the I2NS client, and then in the middle, security management system. This is a security controllers. So you can see we have multiple entities, which means each controller in charge of a single data center. Okay. Also, data develop management system. So if this NSF detects some new attack, this information is propagated to policy collector, and then this guy is making new policy and then delivered to the application logic, and then this guy delivered to new policy into the other security controller, and then we can automatically and also self-adaptively we can disseminate a new security policy. Next slide, please. So we this is an example for VoIP. Okay, so which means some new hacker using some VoIP core from Korea to the continent of Africa in the midnight. That information is propagated to this application logic, and then this guy is delivered to other security controller. Next slide, please. So, okay, next slide, please. So we'll implement this information model and data model for client-facing interface, referring to the super information model. And then we prepare for the hackathon. Susan will help, I believe. Okay. Thank you. Yeah, that's it.
Thank you. Any questions?
I just want to thank you for bringing this idea into a hackathon, and to encourage other people who want to hack away around I2NSF to contact Paul to see how they can cooperate.
And I got a request from China Mobile asking if you do have the hackathon code, can you contribute that into the OpenO project?
Right. Yeah. Okay. So we try to open our code open project. We can share it. Okay. Okay. Thank you.
Lovely. So this remaining piece of the agenda is a chance really just for people to briefly showcase drafts. And to squeeze in, we're going to aim at 5 minutes a shot. So try to resist me having to drag you away from the microphone.
Now we'll present the draft. That is a model for the capabilities. Next slide, please. So mainly the concepts where the draft has been created. So we were imagining in our secured project, an SE-funded project, a scenario where you have a network that may be virtual or physical, and then it has a special topological arrangement, and there are security functions inside. And then at a certain point, you have a new customer or a user that wants to enforce a new security policy. And then you have to understand if with what you have inside your network, you can actually enforce this security policy. This is something that as human beings, we usually do. We understand we need a VPN concentrator, we need a firewall, we look into the specification, we go find it some product, or we see what we already deployed in the network. But the idea is that this process can be automatically performed by computers. So the idea is to automate the policy refinement. To arrive to the second example, where I just write an high-level policy that say I want to filter all the malicious traffic, and I want to redirect all the suspicious traffic to a honeypot, or I want to encrypt all the communications that involve some confidential data. And then at a certain point, this system will build automatically, given the network you already have and a catalog of security functions, what you have, the security, you do the enforcement of the security policy. So this means that we need to understand what kind of policies we can enforce on a given security function. So in this case, we are not touching the part where you want to know how to configure, how to deploy the configurations, how these devices are managed. We want to know from an abstract point of view what the security function can do for us in terms of policy enforcement. And the capability, what we define capability in this draft, and is a concept that will be enlarged by merging more draft, is that the set of attributes, something like a manifest that you attach to a security function, and then you publish with some registration interface to make the security controller aware of the fact that you have this function that can do something for us. And then we didn't concentrate about the client-facing interface, NSF-facing interface that will be probably also named consumer and provider interfaces in the future version. This is independent of who is contacted, because it's a way that a security function has to publish what it can actually do. And this capability in our draft will be abstract concepts, but not so abstract. So they need to be associated to semantics. When I say deny, when I say filter, when I say redirect, when I say encrypt, I need to give a precise semantics, because if we want to build on top of this layer services, this will be understandable. And also when we want to translate high-level requirements like filter malicious traffic or encrypt the communications towards, so that involve private data, I need to understand what is the security function that I can actually use and then select the best one from different vendors and from different producers or developers. So this will be completely vendor independent. Then there could be some data models that further refine a general set of high-level concepts. And the capability model has been built on a policy, an abstract model of policies that by chance is completely coherent with the version on the SHIA draft and the information model provided by SHIA and John Strassner and other authors. And this is one of the reasons why we decided to merge the two drafts. The other one will be presented later. Can you? Okay. So what is this capability model? The capability model starts from general concepts. So mainly as human beings, we decide the security function to use based on the actions that the security function can perform. That may be block traffic, redirect traffic, encrypt traffic, or other different functions. And these are functions that can be actually done on the packets, on the flows, on the protocol data units, so on the active traffic, but there are also side actions like logging what's happening or, I don't know, creating an event to the management system. These are actions that are not performed on the actual traffic and they need to be described in order to understand what I can do with the security function. Then the second pillar of this model are the conditions. So once I know what are the actions that the system can perform, I will understand also what kind of traffic I can filter, what kind of traffic I can redirect, what is if I can recognize by simply looking into the packet fields, or I can also look into the application layer information. And then also what kind of condition I can state, like condition on integers, conditions on strings, like regular expressions. Because when I have to automatically build the configuration for such a function, I need to know exactly how I will use these basics, these capabilities in order to build a coherent policy. And then we also defined other things that need to be used in order to specify a coherent policy. In particular, we had to address two cases. One case is when more than one rule matches the traffic, and then I have to decide what to do. This is usually done with priorities, but there are other alternative resolution strategies. And then if I can also define a default action, if the default action is not possible, if I have to create some other, tricks in order to simulate the existence of a default action and so on. And then, since this can be really complex for a developer or for a vendor in order to describe, we also suggested a way to create templates and an algebra of capabilities where you can start from, this is a packet filter that also features the conditions on time, or this is an application layer that can filter HTTP content, but also some FTP basic information. I don't know. These are examples that are all into the capability layer. And then in order to be compliant with the SUPA model and the other policy models that are of interest into this working group, I also state that events can be supported as native parts, so that are outside the policy model, or they can be simulated as special types of condition, because there is an equivalence. If you want to express event condition actions or condition actions, you can prove that there is an equivalent way to express. It's just a management part, and the event condition action, so ECA approaches are usually considered more manageable. Last slide, please. And this is just to say that we proved that our contribution in the capability model that defines what is the policy that the system can enforce is complementary with the other draft from Shia and Strassner, and we already decided to merge and how to merge it, and this will be most likely done before the IETF 97. Questions?
Thank you. Just a comment. Your work in this capability conflict resolution was really excellent.
Thank you.
And I put the functionality inside of the Yang module for the capability that comes from SheDraft. It's a excellent step forward.
Thank
It's
you very much.
something that I might take back to the routing piece because it actually discusses how policy is resolved. Thank you for your excellent work.
Thank you.
And thanks for the offline discussion. So make it more smooth putting together. Okay, so next one is the capability draft information model. John.
So as Aldo said, this draft is going to be merged with another draft, which is the user group policy capability draft, which will then be merged with Aldo and Diego's excellent work. So don't panic. There's going to be less drafts. Click. So remember what a capability is, right? A capability is the classic IETF may. I've got a function that is available that may be used. It doesn't say you have to use it. It means that the security controller or other management entity is aware of it, and then it will decide or not decide to use it. There's a difference in how these different capabilities or interfaces are used. Put more elegantly, capability is a capability, right? A function is a function. So shame on us if we have to change what a capability means, whether it's a client or a server or a consumer or a provider, right? The concept of a capability should be invariant. What changes is the actor that uses the capability. And so in the information model, these drafts condense. At the data model level, you'll still have these different drafts because they're modeling different artifacts in the implementation. Click. Old, but hopefully still good. So the top is the consumer or client interface. The bottom left is the provider interface. And there's a dedicated registration interface for vendor-specific systems to be controlled. Click. The big changes from version 5 to 6, we redesigned the information model to make it more generic and thereby more extensible. There are now, for example, dedicated subclasses of event, condition, and action that capture the semantics of the policy rule. And these were done completely for network security. Content is getting there, and attack mitigation still needs to be done. Along that redesign, we are in the process of dramatically simplifying the policy rules. So if you read -06, you'll see there's a bunch of subclasses there. What instead we're going to do is talk about how the software pattern works so that you can have 0 subclasses or 1,000. I mean, it's up to you and up to the application. And so this also will help with containing the length of the draft, because clearly if we have 50 classes that each have 10 attributes, this is a 1,000-page draft. No one wants to read that. I certainly don't want to write it. So instead, by telling you what the software pattern is and how it's used, right, we then have a simple appendix. Here's, a DDoS scenario, and this is how the DDoS policy rules and events and conditions in action looks. Here's a DPI scenario. Here's maybe a third scenario. Boom, we're done. All less than 50 pages. Everyone's happy. Click. So the 3 things that we're covering: network security is in great shape. Content security is moving right along. attack mitigation, we ran out of time, but there's no hidden gotchas. It's just we needed the IETF to be another 2 weeks later. Click. This is the overall information model design. Thanks to some comments, we made a minor correction in the figure here. So what we're basically saying is that this model fragment can be subclassed from anything. If you want to use SUPA, great. If you want to use something else, great, right? All we require is metadata, which, by the way, is the solution that's used in Aldo and Diego's draft. So we've got good alignment there to control the semantics of what the policy rule is. So the policy rule is just a simple container. The semantics are defined by the event, condition, action tuple that you put in the container. And so that makes everything a lot more reusable. Click. This is the pattern that we've decided on, or one of the patterns, there's actually several, that we've decided on, that is in -07 as we speak. I don't really want to go through the rest of it because there's going to be some minor adjustments as we merge. But basically on the left, what you see is the policy rule is just a container that's controlled by metadata. And on the right, when I apply this policy rule, the policy rules can in turn be orchestrated or choreographed with policy rules from a management plane. And so that association class, security ECA rule detail, allows you to define which security methods will be used by this particular policy rule. Click. This is a small part of the event hierarchy. You can see that there's a number of event classes and there's some quick attributes. No, I'm not going to read them. Click. Same for condition. Click. Same for action. And if we click one last time, this is the existing content security model that is in the process of being transformed into a proper UML model with classes and attributes. Another click, you'll see the same thing for attack mitigation. A last click, I think, is we're going to first get the terminology consistent. There's a couple minor things, but that depends on whether we change things in the framework and terminology drafts. Then we'll finish the two submodules and then merge with Aldo and Diego's capabilities draft, and then also incorporate the user group policy capability, which is basically a user group label into this. And at that point, we'll hopefully be ready for working group adoption.
Thank you. Any questions?
Yeah.
Well, it's a big document, so please go ahead and then spend some time reviewing it.
It's small, getting smaller.
Getting smaller, yeah.
It's amazing.
I heard that.
No, it's really hard to make a document small.
Well, thanks. We're trying.
So this one, no, I got just like this. Next one is, this is one by IPsec. So are you ready, Rafa?
Yes, I'm ready. Can you hear me?
Oh, yes, very loud and sound.
Okay, thank you. So thank you for giving us the opportunity to present our ID. I will try to be quick. Basically, the idea is to, next one, is to manage, next slide please, is to manage the IPsec Security Association, it's the previous one, sorry, previous one, introduction. I'm seeing, okay, this one. Okay, so the idea is right now, IPsec Security Association are manually configured by the administrator, which means the administrator needs to go to the network devices, configure all the policy when you want to protect the traffic, the flow, with some particular protocols in IPsec, AH or ESP, whatever. And then that makes the security association management difficult if something changes. So what is the idea? To have a centralized point, like a security controller, to manage all the security association based on IPsec. That would mean, as we will see in the presentation, key management, key distribution, policy distribution, etc. So that's the main idea of our ID. Next one. So interestingly, IPsec architecture allows a separation between the protection of the IP flow, I mean the IP traffic. For that, you have several databases, usually in the kernel of the operating system of the network device, and other part that is separated usually in the user level as a user level application, like key management protocol, like IKE. Then you can negotiate and establish that security association. But that is clearly separated in the IPsec architecture. So our idea is, okay, let's try to perform the key management from the centralized point, which is the security controller, and then we can enforce some kind of information over all these databases to say when the traffic needs to be protected. So somehow the key management procedure moved to the security controller. So next one. So this is a first case we have considered. See, you have one, this is the network security function. The network security function will implement all the IPsec stack implementation with all the databases, the security policy database, security association database, peer authorization database. And in this case, we are considering also including an IKE implementation in the network security function. So from the controller, we can send IKE credentials, keys, information related with IKE, and then we can send policies that are included in the security policy database and the peer authorization database. So that information is sent to one network security function and to another network security function, which is the other endpoint to establish the IPsec security association. So with that information coming from the security controller, those network security functions can establish that IPsec security association. We will see an example later. So another case we're considering, next slide, please, is where the network security function doesn't have IKE implementation, just the IPsec stack implemented, let's say, in the kernel of the network security function with the three databases. So the controller, the security controller, can distribute key material and information to enforce all the required information. And then, in the case a flow matches the security policy in the network security function, the network security function has all the information to encrypt or add integrity to the IP packets traversing the network security function and going through to another hub. Next slide, please. Here is an example. Let's assume, this is the first step, let's assume an administrator provide a general flow protection policy. I want to protect traffic from this network to this other network with confidentiality, whatever. Then the security controller will translate that into IPsec security policies and then will enforce that information to both network security function involved in both end networks. So with that information, with some flow is coming, then all the information is already the network security function can start, for example, in this case, in this example, is starting IKE with the other network security function number 2, and then you establish the IPsec security to protect all the flow between both networks. The example is, for example, from headquarters A to BO facilities, for example. So next slide. Interestingly, we think this is important for this working group. Interestingly, we already have an RFC specifying how to manage the security association database, how to add the security association entry, when it has to expire, remove that security association, when a security association is required. So that kind of even an interface is already defined there. Of course, that is implemented using a socket, and the assumption is you have a key management protocol on top of this ABI. But at least we have information about how the NSF facing interface should shape, in the sense what kind of information we have to allow, or we have to enforce, or what kind of events we are going to receive from the NSF in case we need to handle the IPsec Security Association. There is another extension. The truth is, it's not the standard. It's coming from the CAME IPsec stack, but also to manage the SPD database. In the SPD database, we have all the policies. So you can add a policy, remove a policy, send in an event when you require the policy. That one is acquired. But those are right now the kind of interfaces we already have there. But we don't have any specification or any standard or any document specific what kind of parameter we want to, what we need for controlling the IKE implementation. Neither that one, neither nor the PAD database. So somehow that is a part of our future work. Actually, in the next slide. So we are doing some ongoing work. Of course, in general, we will require a model to configure the SPD in the network security function, the ASD in the network security function, the PAD, and the IKE implementation. What is true is we have seen out there some kind of drafts with jam models, precisely modeling this kind of information you need here. But we are still in the process of verifying that and contrasting that information in those jam models with the ABIs we have seen in the previous slide. So in some sense, in our draft, we're not specifying many details about what kind of information we need in the NSF facing interface, because we think part of the work is define somewhere else, and then we need to look at that. But our draft is showing a need that maybe in this working group or in general, we need some kind of a way to push key material, key information, and in general to perform key management. And then we need those interfaces to send that information to the network security function. As a note, a final note in this presentation, I would like to say that we have a short proof of concept using I think phase 2, where we have two network security functions. We are using the Linux kernel and with setkey, and then with netconf, we are applying that configuration to establish an IPsec security association. And that's all. I hope it was quick. So any question?
Yes.
Okay. Darok from Inside Secure.
Okay.
First of all, the PF key interface it's very old. It's
yes,
for
I know.
And it doesn't take any account into the new model of the the RFC 4301, the new architect model. So it's probably might be better to actually make a completely new one than to try to use that one. There might be some functions there that are usable, but if I understand correctly, those people who are using it have always make their own extensions, like you said, the Kame had already done. They might use some of those old functions, but usually they add some things that they needed, to use ranges and that kind of things. The other thing is that there is that in IKE, the new current model is that it's always assumed that the key management and the traffic flow they are integrated together, so that if one fails, both of them fails. So you can't move the key management function to a separate node run it there and then run on, you know, compression or encryption on the other node, unless you make sure that if one of those nodes fail, both of them fail. So if the key management dies, the essays must, the IPsec essays must go all away also. So you can't have, you know, these kind of things that only one of them dies, because the key management takes care of the saying, oh, is the other one is live, and if it's live, then it assumes that I don't need to do anything. If the IPsec dies without him knowing, then he can't, you know, fix the situation, and other way around. So, and also, you know, the databases, what you are, I actually wasn't completely sure what you are trying to do here, but it sounds very scary.
It isn't for us, but.
Yovnir, so you presented two cases, one where the IKE is performed on the SDN controller and one when the SDN, when the IKE is performed on the security function. And so as Tara said, that they have to either live together or die together. But in addition, IKE performs few extra functions such as detecting a NAT between the two, the two security functions. So if you run the IKE not on the same place where the IPsec is performed, then you're probably getting wrong results. Additionally, if you have where you place the SDN controller, that you have it's not necessarily reachable. So if you get two security functions that are not under the same SDN controller, so you have to perform IKE between the SDN controllers, nobody guarantees that you can even reach the other SDN controller. It might be deep inside some corporate network, hidden behind the NATs, or and having a non-routable IP address. So I think the case one, I think the one with the IKE performed at the security function is the better option.
Okay, may I say something? Sure. The thing is, in our point of view, even in the case two, the assumption is the security controller, in general, a centralized controller, will have a picture of the whole network. If some kind of NATing or problems related with your mentioning, that should be somehow known by the controller. So it's something it's required in the network security function at that level you're mentioning. It should be known by the security controller, even in that case. And regarding having two security controllers, we already have some comments in our ID. We have some, just one example. With obviously, the simplest one is one controller. But I agree with you. I mean, you need to coordinate both controllers. One controller needs to know the state of one of the network security function that will be involved in that IPsec security association, and the other controller will have to do the same. I agree. And that is a complicated scenario, and that's why we need some kind of east-west interface capabilities there in order to manage those security function. Those IPsec security association between both network security function. Of course, it's a more difficult scenario. I agree.
Well, come to think of it, if you have only one SDN controller, then there's really no point in performing IKE.
Right.
Randomly generate the keys and push them down, and there's no need for
there is. I agree that obviously to us in case two, having only the IPsec stack, you have a simpler network security function. But it's true that you can also provide the IKE credentials, because in the end, IKE is doing something for you in the network security function. You don't bother too much to the security controller. So, for example, doing the rigging of the security association, usually IKE is doing that. Mm-hmm. If you configure correctly, IKE will do that. So that's one advantage of having IKE in the network security function, even when you have one security controller. That's one advantage of that. If you remove the IKE implementation for the network security function, then that is part of the security controller knowing the state and, for example, receiving some events and then if you want to do some kind of rigging, that is coming from the security controller. But instead, or in contrast, you have a simpler a network security function, not having the IKE implementation, I mean.
Seems this is a very complicated subject. Do you think we can have like a interim, just have a web conference to discuss in more detail? Maybe we can go through the mailing list, find a time everybody's available to discuss it offline.
Yeah, we're fine. Yes.
Okay, so the next one, the question very quick. You can ask if it's long, then let's hold it to.
I'll just make it a quick question. Paul Wouters. IKE does a lot more than just negotiating over the network. It also does things like looking at the capabilities of the host it's running on and to making sure that some things should or should not be negotiated. So, for instance, you have things like Linux kernel bugs with truncation for SHA-2, whether or not a kernel supports extended serial numbers, all these other things. So I think it's a really unwise decision to remove that IKE from the IPsec configuration. I think you should just settle for using IKE and not having...
Just a short comment. The IPsec architecture mentions that IKE is just the default key management protocol. So the IPsec architecture allows another kind of key management procedure. So of course we have IKE, but we have other alternatives, and our idea, of course, is using the security controller for doing that, at least in the case 2.
Okay, last one.
Yeah,
quick.
Brian Wise from Cisco. So I would just echo the other commenters. So option 1 is really the safest approach, because it looks like IKE and IPsec are independent, but they're not so independent. For example, if you download an SA, essentially the SAD, and then you re-download it and reset some state, that would be a really problem if you're resetting things like sequence numbers, or if you reinitialize SAs that are a counter mode SA and you reinitialize the crypto state, you can cause problems and so on. So there are some issues. Yes, by the way, I agree, and I have written other key management methods for IPsec besides IKE, but you have to be really careful about it. I'm not so sure about just downloading stuff from a controller. It would have to be a little bit smarter than that, I think.
Sure.
Okay, let's have it offline then.
Okay.
So
thank you.
We only have 15 minutes left. So we need to hurry up. So the next one, Sue, are you going to present this joint? Okay. Oh, I thought. Okay. Oh, you need this one.
Then once I finish with the first one, shall I just cover the second one off my projection? Yeah. Okay, I'll do that. Give me a second.
So this is the joint draft.
This is the joint.
Good, thank you. As a result of our site meeting, we merged some drafts.
Yeah. Okay, so can I have the mouse plug in?
I'll press it forward.
Okay, just press it forward. All right, I'm sorry. I might need that. Okay. No, I picked up the wrong one. I'm sorry. Don't need that one. See why you do this ahead of time? Excuse me.
Is this the one you sent to me? This one?
That one, but it's the other one.
Okay.
I'm sorry. I'm having trouble seeing it in the middle. There it is. Pardon me.
Okay.
Okay, so I will go through both, and if you will get through the first one. I will try to do this rapidly with Linda's help. So this is a beginning Yang model draft for the capabilities. Go ahead to the next one. Just click down, yes. This is the model. This is to tell you we are trying to align it with the G capabilities. It comes out of it. Go ahead. You've seen this in John's presentation. You've seen that in John's presentation. Okay, now there's one piece, and I hope I can provide this input also for Kathleen. So just a moment. What we did is I'm utilizing a common packet processing that does the event condition action filtering, common between the stuff that we're doing in routing and the stuff we're doing here in security. That way, when we go to compare stuff for routers or for switches that are for security boxes that might have routing, we don't have a trouble in actually processing the filters that might filter prefix or stuff in the packet. Why is that important? The note from Aldo that said we want to have mechanisms to be able to conflict resolution, it enables that. So we have this common packet. We then went through and had the network security. There's a contact capability and there's a migrate capabilities. And based on the feedback from Aldo, there's IT resource. Go ahead. So this is just going to walk through briefly. I'm going to hit the highlights and assume that you can look at the Yang model and see if we've missed anything. Paul and I are going to work on a joint demo, and I'd like to suggest you create a hackathon GitHub directory for I2NSF. I will help that. So again, the thing that's different between Paul's and mine was I did a little something we are doing that may be helpful operational. In other words, there was a link between groups and actual rules. It doesn't change the rules. It just provides a case that if you have a customer, China Mobile might have a customer, this enterprise, that you could track the rules by that particular mechanism. Go ahead. So that was showing you that we went to traffic in expansion rule. We haven't really done authentication or authorization. We're on a particular piece. Go ahead. And it shows that we have rule match condition, rule action policy, external data, installed status. Now, the thing that you all didn't do that the NetConf folks and the routing folks are doing is operational state. I assumed that you wanted to track how many times your filter had been matched. Based on your comments this week, I think I'm aligned with actual policy. Whether that match on security is sufficient, that I need a lot of feedback on. But op state is, excuse me, how many people know what operational state is here? Okay, few nerds in the back, let me at least be polite and say it. Operational state is the state which is generated based on actual functionality. It's statistics and status. So statistics on count. Okay, next. This follows the model. The one question we have is I treat capabilities as a function to be queried, which is what John was talking about with capabilities. John treats them as actions. Go to the next one. This just goes through the fact we're using time, John, and user in the latest version, and the match. Go ahead. I think we don't need, this is, if you're in the middle of it, it's fine. Go ahead. If you have questions on this detail, go catch me after. Here's the actions. I have, in my draft, I have a much more extensive action pace based on ingress, egress, output, QoS. This links it to some of the other work that's being done in the routing and routing firewalls. Okay, next one. This is the conflict resolution policy that Aldo was talking about. I'm just highlighting the text. Read it. Talk to me afterwards. I'd love to talk about it. Okay, next. External data is because Aldo said that sometimes you want to to have that for your resolution. Next. Okay, here's the point that's in John Dong's. When he gets down to the end of the piece, when he has event condition action, he actually cycles back and says, okay, we're gonna engage a mitigation feature. That's different than just having knowledge of the mitigation feature. So the policy rule can say, go ahead and mitigate this. Next slide. We've done that. Go ahead. Oh, okay, then I'll have to say it verbally. My whole question, if you'd switch over to Zhang's procedure, the whole question for the working group is whether we should allow both the capability recording and allow policy to enact it. So John?
So I need to read this because you went kind of fast.
Yeah, I did. I have a short time.
Two quick comments. One, be careful on groups because in Yang you're going to run into recursive containment problems. So I'm not sure.
I got the Yang stuff to compile.
That doesn't necessarily mean it'll run.
Yes.
Number two, you had something called policy conflict resolution in the configuration, which is probably a longer thing, but I don't think that's actually configuration, right? If I've got a conflict between two policies, then that will be resolved and a third policy will be done.
I'm going to put a pin in that because actually Aldo suggested we could, and that's a really good long discussion that I would love to have on either an interim or in the hall afterwards. But I'm following the paper that Aldo put out on the thing. Yeah, really cool new stuff, as I said to Aldo. But we should talk about that and see if it's right. I don't know if it is. I'm just did it. Junk stuff is here because we just didn't include in my slides the VOE. Do you want me to? I'll do the slides when you talk.
Yeah.
No, just.
Okay. He's got it.
So I think the 20 seconds is enough to highlight. So Susan already explained. This slide explains the additional stuff such as the VoIP LT from Korean Telecom input. Next slide. So this shows the generic data model. Next slide for the VoIP LT. Next slide. So you can read this slide to how to model for Yang model for VoIP LT reality the application for the security services. Next slide. So this we based on event condition action. Next slide. So you can looking at the condition, especially SIP case, how to handle of ECA concept. Next slide. Yeah. Yeah. So Susan will include this the use case into the merge draft, right? Next slide. Next. So next step is we merging, and then we can working for the developer for the hackathon. Okay, that's all. Thank you. Yeah.
Thank you.
Good. So we were doing so well, and then we discovered that if you try to put 25 drafts into the remaining 6 minutes of the meeting, it doesn't fit. So we've got, I think, 4 drafts listed on the agenda that we don't get time for this time round. Please read the slides. Please talk to the authors in the corridor and discuss it all on the mailing list as well as everything else. And Diego wants to say he posted an email to the list during the meeting about some security stuff that came up in his NFV research group that you should also have a look at. And that basically completes us until we either have an interim or we go to Seoul. So use that mailing list. Thank you.